Okay, the next thing we're going to learn is birthday cake factorizations, and they are my favorite thing to do in math. They are kind of cool for some reason, and I really like them, so I think you will too. So the first thing we're going to do is to learn the definition of prime factorization, and then learn how to find the greatest common factor and least common multiple through the birthday cake method. So let's start with some definitions. Now remember, when you're writing down, if you see a word in red, that gets written on your paper. I have everything else filled in for you. Also, you need to write down all of the examples. So our first definition is prime factorization. Prime factorization is a number written as a product of primes. Remember, a prime number is a number that has exactly two factors, one in itself. So kind of the kid way to say that is a number written as only prime numbers and they're multiplied together. So when we find prime factorization, it's going to be a number broken down into only primes that are multiplied together. Prime factorization is like a number's fingerprint. No two numbers are alike, so no two numbers have the same prime factorization. Just like my fingerprint is different from your fingerprint, numbers have different prime factorizations. So to find the birthday cake factorization, your first step is to make a cake for a given number using only primes. Step 1, always use the prime numbers 2, 3, 5, 7, 11, and 13. Yes, they go on forever, but these are the ones we use the most. Step 2, make your cake by dividing by your primes. You start with 2 on every layer until it's not a factor. Then you go to 3, then to 5, and then to 7, etc. Only using prime numbers. Remember, it's called prime factorization, so you can only use primes. So when we do this, we're going to use 2 until we can't divide by 2 anymore. Then we'll go to 3 until we can't divide by 3. Then we'll go to 5, and this will make more sense as we go through it. So if this example, you can see I'm trying to find the prime factorization of 16. So I have 16, and then I have a cake layer on it. So I want to see if 2 goes into 16, and it does. 2 goes into 16 8 times. So 2 goes into 16 8 times, so I put an 8 up above. I draw a layer, and then I check 2 again. Does 2 go into 8? The answer is yes. It goes in there 4 times. So I write my 4, draw a layer, divide by 2 again. 2 goes into 4 2 times. So I have a 2 here. 2 goes into 2 1 time. And that's how we know when we're finished. When you have your candle or a 1 at the top. So all we did was we used 2. 2 goes into 16 8 times. 2 goes into 8 4 times. 2 goes into 4 2 times. 2 goes into 2 1 time. That's the prime factorization of 1. So we wrote it as prime numbers. Now we have to multiply them together. And the way you do that is it's going to be all the 2's multiplied together. So 2 times 2 times 2 times 2. And if you multiply it out, 2 times 2 is 4, times 2 is 8, times 2 is equal to 16. It's the same number I started with, and that's what we'll always get. Okay, so let's try this. We're going to find the prime factorization of 12. So the first thing that you do is you kind of leave yourself some room because you have to work up. You write your 12 and then a cake layer. Remember, we always use these numbers right here. 2, 3, 5, 7, 11, and 13. So, does 2 go into 12? The answer is yes. 2 goes into 12 6 times. So we do a layer. We have to keep doing layers until we get the number 1. Does 2 go into 6? Yes, it does. 2 goes into 6 3 times. So we draw another layer. Does 2 go into 3? No. So I'm done with the 2. So now I move on to 3. Does 3 go into 3? Yes. It goes in there one time. I have my candle, so now I'm finished. The prime factorization of 12 is 2 times 2 times 3. This is your answer right here. The cake is not your answer, it's the work. 2 times 2 times 3, that is your answer. Okay, your turn. I want you to find the prime factorization of 27. So start from scratch, do the prime factor of 27, go ahead and hit pause, and then when you think you have it, hit play, and we'll see if you're right. Okay, so your birthday cake should look like this in blue. That's the cake, remember? And you couldn't use 2 because 2 doesn't go into 27, so you had to move to 3. This is your answer in pink. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. And that's the number I started with. So if you got that right, good job. Okay, so I said I really like birthday cake because you can do a lot of things with it. One of the other things we can do is greatest common factor. So we're going to find the greatest common factor of 12 and 24 by doing birthday cake. You do it the same exact way. You just have 2 numbers now instead of 24. So remember, when you do birthday cake, you use certain numbers. You will use 2, 3, 5, 7, 11, and 13. Use them in this order, and you're using them, why? Because they're what type of numbers? Prime. You got it. If you said prime, you did an awesome job. All right, so let's check 2. Well, actually, let's write our 12 and our 24 into our cake. And we're going to check 2 first. Does 2 go into both of the numbers? It has to go in both of them, not just one. And it does. 12 and 24 are even, so we know 2 does. 2 goes into 12 6 times. 2 goes into 24 12 times. So we do a cake. Now we're going to check 2 again. Does 2 go into 6? Yes. Does 2 go into 12? Yes. So we're going to divide by 2. 2 goes into 6 3 times. 2 goes into 12 6 times. So we do our cake. Will 2 work here? The answer is no, because 2 doesn't go into 3. 2 goes into 6, but not 3, so we can't use 2 anymore. So now we try 3. 3 goes into 3 1 time, and 3 goes into 6 2 times. And we're done. And the reason you know you're done is when your top layer, they're either both primes, or they are next to each other in the number line. And 1 and 2 are prime, so I know I'm done that way. And they are next to each other in the number line. But I haven't found my greatest common factor yet. And the way that you do that is you use the G in greatest common factor, and you draw a G right there. So that G is around the 3 times the 2 times the 2. So let's multiply that together. 3 times 2 is 6. 6 times 2 is 12. So the greatest common factor, the factor that 12 and 24 both have, is 12. Pretty cool, huh? Okay, now it's your turn to try a greatest common factor of 18 and 36. So go ahead and try it. Hit pause. When you're finished, hit play, and we'll see if you're right. Okay, look at your cake. Does your cake look like my cake? It should. So if it doesn't, see if you can fix it. And the answer you should have gotten is 18. 18 goes into 18 one time, and it goes into 36 twice. So it's a factor of both of them. Okay, and then the last thing we can do is we're going to do least common multiple. So we're going to do it of 24 and 16. So again, you do birthday cake the same, whether it's a prime factorization, greatest common factor, or least common multiple, you're always doing the same thing. Your answer is just going to be depending on what you're finding. So we're going to do 24, 16. We start with 2. So remember, we do 2, 3, 5, 7, 11, and 13. 2 goes into 24 12 times. 2 goes into 16 8 times. We try 2 again. 2 goes into 12 6 times. 2 goes into 8 4 times. So we try 2 again. 2 goes into 6 3 times. 2 goes into 4 2 times. And I'm finished because 3 and 2 are next to each other in the number line. Now in this problem, I'm trying to find the least common multiple. Well, that begins with an L. So what I'm going to do is I'm going to draw an L through my top layer and through the bottom. Now, whatever number that L hits is part of my least common multiple. So it's 2 times 2 times 2 times 3 times 2. All I did was just take each one of these numbers and put them in my list. Now we're just going to multiply together. 2 times 2 is 4, times 2 is 8, 8 times 3 is 24, 24 times 2 is 48. That's my least common multiple. An easy way to remember it, again, is the L and the L in my cake. Okay, so that's birthday cake factorizations. Like I said, it's my favorite thing. It's awesome. So I will see you in class to make some birthday cakes.